A coolant widely used in automotive engines is 38.70% carbon, 9.744% hydrogen, and 51.56% oxygen by mass. It has a molar mass of 62.068 grams per mole. Determine the molecular formula for the compound. If you're given this type of problem, the first thing you need to do is to assume a mass of the compound. So you can pick any number you like. But if you want easier calculations, we usually assume 100 grams of the compound. So why 100 grams? If you assume 100 grams of the compound, the percent by mass of the element becomes the mass of the element. So for example, the problem says it is 38.70% carbon. So if you assume 100 grams, 38.70% becomes 38.70 grams of carbon. If you have 9.744% hydrogen, you have 9.744 grams of hydrogen. And if you have 51.56% oxygen by mass, you have 51.56 grams of oxygen. So it's easier if you assume 100 grams of the compound. Next step you need to do is to convert each masses into moles of the elements. So let's start with carbon. The mass of carbon is 38.70 grams. To convert this into moles, we need the molar mass of carbon. And the molar mass of carbon is 12.01 grams per mole. So you put 12.01 grams at the bottom, and on top you put 1 mole of carbon, so that the grams of carbon will cancel and you're left with moles of carbon. So if you solve for the moles of carbon, this is equal to 3.22 moles of carbon. Let's move on to hydrogen. We are given 9.744 grams of hydrogen. The molar mass of hydrogen is 1.008 grams per mole. So same thing, you put 1.008 grams at the bottom, and on top you put 1 mole of hydrogen. Grams of hydrogen will cancel. Then you solve for the moles of hydrogen, which is equal to 9.67 moles of hydrogen. And finally, we compute for the moles of oxygen. We are given 51.56 grams of oxygen. The molar mass of oxygen is 16 grams per mole. So you put 16 grams at the bottom, and on top you put 1 mole of oxygen. So grams of oxygen will cancel. Now you have moles of oxygen. And if you solve this in your calculator, moles of oxygen is equal to 3.22 moles. Now that we have the moles of oxygen, we can determine the empirical formula. So how do we do that? We have 3.22 moles of carbon. We have 9.67 moles of hydrogen and 3.22 moles of oxygen. Now compare the moles of each element and choose the smallest. So between 3.22, 9.67, and 3.22, the smallest is 3.22. So what you do is you divide all the subscripts by 3.22. So you divide this by 3.22, divide this by 3.22, and divide this by 3.22. So this becomes, for carbon, 3.22 divided by 3.22 is obviously 1. For hydrogen, we have 9.67 divided by 3.22, that is equal to 3. And for oxygen, 3.22 divided by 3.22 is also equal to 1. So C1H3O1 is what you call the empirical formula. So this is not yet the answer to the question because the question is asking for the molecular formula. So how do we determine the molecular formula? We need to find first the ratio between the molar mass and the empirical mass. So according to the problem, if we read this, the molar mass is given 62.068 grams per mole. So let's put the molar mass, 62.068 grams per mole. How do we solve for the empirical mass? So we already have the empirical formula C1H3O1. So to solve for the empirical mass, we have 1 times the molar mass of carbon, 12.01 grams per mole, plus 3 times the molar mass of hydrogen, 1.008 grams per mole, plus 1 times the molar mass of oxygen, 16, let me write that properly, 16 grams per mole. So if you solve for the empirical mass, this is equal to 31.034 grams per mole. So let's plug this number into the formula for the ratio, 31.034 grams per mole. So if we solve for the ratio, that is 62.068 divided by 31.034, which is equal to 2. So the ratio between the molar mass and the empirical mass is 2. So how do we use this ratio to determine the molecular formula? So remember that we already solved for the empirical formula, C1H3O1. What you need to do is you multiply the ratio to all the subscripts. So for carbon, it becomes 1 times 2. So that is C2. For hydrogen, that's 3 times 2. So H6. For oxygen, that is 1 times 2. So that is O2. So the molecular formula of the compound is C2H6O2. And this is the answer to the question.